Okay, and with composition of functions, here's what we're doing. You can say one thing, you call it whatever you want to call it. Basically, here's what you're doing. You're going to plug one function into another function. Okay, so that's what composite. Now, it's not addition, it's not subtraction, it's not multiplication and division. It's taking one function and plugging it into another function, and it's going to be written a couple of different ways. It could be written like that, where you've got like g of x is on the inside of parentheses with f first. Now, sometimes that gets a little bit confusing, so they might actually write it like this. Yeah, it looks like fog X because it's a multiplication symbol, but it's an open multiplication symbol. So it's basically like just an open circle. So it looks like fog X. I mean, it's not what it is. It's f of g of x is the way you would read that. Okay, now here's the big thing. These are always going to spin off. Which one is closest to x? G is closer to x, whether it's written like this or like this, right? So this means you're going to plug g of x into f of x. So whatever's closest to x is the one you're plugging into the other function. Bless you. Okay. And then the other way is just reversing the two letters. They're going to put the g first and then the f of x second. Oh, I had too many parentheses on that one. Okay, so we've got g of f of x, which when you write it that way, it looks like golf or golf. Go for golf, ever how you want to say it there. But really, it's g of f of x is what it's saying. And again, for this one, because f of x is closer to the f, you're going to plug f of x into g of x. Okay, and it's just a matter. When I was going through this one, it took me. I'll show you what I did to kind of get through this one because I struggled a little bit at first, and then once I figured out that this was what I was doing, it made things go a little bit easier. And once I had that going, everything else seemed like it started clicking after that. So. All right, so what we're gonna do, we're gonna start you off kind of easy here. Start you off with some expressions that aren't too complicated, and then once we got the easy ones out of the way, then we'll build up to the tough ones after that. Okay, so f of x is going to be x plus 2. G of x is 4x minus 3. Okay, and we'll do both cases. We'll do f of g of x, and then we'll do g of f of x just to make sure that we're okay. And the answers are normally going to be different. Occasionally, you may get one with answers the same, but most of the time, if you do a different operation in a different way, you're going to get two different answers most of the time. So, all right, so for this one, let's go with part A. Let's get f of g of x. Again, which looks like fog x. Okay, and what finally clicked with me when I was going through this and where I struggled with a little bit was I actually would write it down, the red part we've got right here that I know that I've got to plug g of x into f of x. And I know for a math class to write something down with words is a little odd, but it works when you do this one. So then just write down what it is. G of x is 4x minus 3, and f of x is x plus 2. And when you're plugging it in, you're taking the entire function you've got here, and you're going to plug it in for x. Yes?
With on homework and on assignments and stuff, will it tell us if we're supposed to just be doing the function of operations, or will it specify like when we have to do the composition? Don't they kind of look the same?
It does, but composition will always be the open circle. And if it's multiplication, it'll be a solid circle.
Okay.
Okay, so where you've got the x, take out the x, and you're going to put 4x minus 3 in its place, and then plus 2. And then once you're there, then we're back to what we were doing yesterday with the order of operations, that now we're taking the order of operations, and you're going to work through the order of operations and do add, subtract, multiply, divide, whatever it says to do in this case. In this case, it's just addition. So it's 4x minus 3 plus 2. So we've got the minus 3 plus 2, so that's 4x minus 1. Okay, so that's what we had to do yesterday, was make sure you're okay just doing the basic operations, because the composition takes the operations yesterday and then just makes us do that today. All right, everybody okay with that one? All right, so let's go the other way just to make sure we got it, because this one actually will look a little bit. I get this way actually will kind of look a little better, I guess. Makes you do a little bit more work for this part. So g of f of x means we're going to plug f of x in the g of x. And I know that's a small step to actually write down those few words, but for me, that was the key. That was the trick for me when I did this, to make sure I knew which one was going where, because sometimes I got off for this thing. So f of x is x plus 2. G of x is 4x minus 3. And again, we're going to plug it in for x. All right, so taking out the x, putting in x plus 2. Everything else around the x goes outside the parentheses. So now we've got 4 times x plus 2 minus 3. Which means for this one, it's not just, now we got to do a little bit of multiplication. We got to do a little distributor property. So now you've got your 4x plus 8 minus 3. So then 8 minus 3 is 5. Okay, a little bit of difference. Not a huge difference, but again, just enough of a difference that they're not going to be the same answer. And that's going to be the case probably most of the time. There'll be a few times where, and actually we'll talk about that in a little bit, where you want to look for the same answer in both cases, and then that's something special if it is that case. Okay. Everybody good there? So far, so good? All right. One of the other things they're going to do after this one, and usually they should do it this way, they're going to ask you to, find f of g of x and g of f of x. And then usually the second thing they're going to do after they do one of those two options is they're going to give you a number. So it's going to be g of f, and then they're going to throw in a number for this thing. So it looks like golf 10, but it's g of f of 10. Okay. Well, yeah. So what we're going to do is, if g of f of x was 4x plus 5. So basically now we're doing like we did before. Instead of having x, you have 10. So everywhere you have an x over here, you're going to take out the x and you're going to plug in a 10. So basically that's just a fancy way to evaluate the function when x equals 10. So again, function notation is always something to kind of shorten this thing out. So if you've got g of f of 10, that means you're going to plug in x equals 10 in a g of f of it. So it's just a shorter way to say, take the number we got, plug it back in, and evaluate this thing. So then it's 4 times 10 for 40, plus 5 would be 45. Okay, so when they give you a number, just go ahead and do the g of f part. So that means you're going to plug f of x and the g of x, figure out what that is, and then they tell you this number. Just take that number, plug it back into your answer, and then just evaluate. So same thing we've been doing, just again, the notation is just a little different as we're going through that. Okay. All right, let's step it up a little bit. If everybody's okay with that, let's make one that's a little bit tougher here. Okay, so for example 2, let's say f of x is x minus 5. And then g of x is x squared minus 2x plus 3. Okay, and instead of doing both cases here, we're going to just do one. Because again, they're both pretty similar to it. So if we just do one of these, we should be okay. So the very first thing we're going to do for this one is let's go ahead and find g of f of x. All right, and again, this is just me kind of going back to when I was doing this. I had to kind of write this down that I know I'm going to take whatever is closest to the x. I'm going to plug that part into the first number. So I'm plugging f of x into g of x. Okay, so f of x is x minus 5. G of x is x squared minus 2x plus 3. All right, big difference on this one is x minus 5, there's two x's, so it's going here. And it's going there. So you got to plug it into both places. So everywhere you've got an x, you've got to plug that in for the variable x every single time. All right, which means on the first one, we get to do everybody's favorite. It's x minus 5 squared. And because it's x minus 5 squared, we get to do the, oh yeah, everybody says, yeah, it's the full method. Woo, right? Woo! Okay. All right, so if we FOIL out the first part, the x minus 5 times the x minus 5, that's going to be x squared minus 5x. The good thing is when you do the same thing twice, the middle number here is going to be the same. Another minus 5x, and then negative 5 times negative 5 is a positive 25. All right, you can combine these terms in the middle. So that's x squared minus 10x plus 25. Okay, and then we still got everything else back here. We've still got to do distributive property with the negative 2. So it's negative 2 times x, 4, and I'm just going to drop it down here at the bottom, negative 2x, and then negative 2 times 5 for a positive 10. And that plus 3 is just hanging out on the end out there because we didn't do anything to it, so it's just the plus 3 that's there. Okay, and then, yeah, now we've got all the like terms we can go back and combine together. We've got the x squared. You got a minus 10x and a minus 2x. So it's minus 12x. And then we've got the plus 25, the 10, and the 3. So that's 25, 35, and 38.
Did they ever have us factor from there? Like would they ever say or like sign?
No, since it's just order of operations, there shouldn't be any factoring on those. Okay. Good question. Okay, and then one more little tail end piece on that one is that a lot of times, and again, that's our g of f of x. And a lot of times that one, as soon as they give you that, usually the next step is then going to be the part B. Is they're going to ask you to find g of f of, and then again, they're going to give you that number. Let's say it's negative 2. Okay, so again, everywhere that there's an x, now you're going to take all the x's and replace it with negative 2. So that's going to be negative 2 squared minus 12 times negative 2 plus 38. Okay, and it's just order of operations from there. Just plugging through the numbers. Just be careful of the, especially with negatives, be careful of the negatives. Negative 2 squared is 4. Negative 12 times negative 2 is a positive 24 plus 38. That's what, 28 plus 38, that should be 66. There you go. Okay, so it's order of operations, which is what we're doing yesterday, and then evaluating, which goes back to, it seemed like that was what, a month ago, 2 months ago, been a while back. Okay, in composition, that's about as complicated as it gets. It's just taking one function, plug it in for x and the other variable, and then work around through it. Okay, so here's the next thing we're going to do with this one, is that sometimes, depending on the numbers, depending on which way you plug it in, there's certain things that we're going to look for when you do f of x and g of x. And the special thing that we're looking for is what they're going to call inverse functions. Okay, and with inverse of functions, the basics of it is that you're going to swap your x and y values. All right, now this is going to make you go back probably a month or so ago. Does anybody remember what makes a what makes a relation a function? Since we're talking about functions for this thing, anybody remember, Corbin?
Doesn't repeat y values.
Doesn't repeat, not the y values, but the x values, right? So that you can have repeated y values, but yeah, you cannot repeat x values. It's, we were talking about if you go, out the vending machine and you push the button for Mountain Dew and you get a Diet Grapey Coke. Yeah, you're like, that's not what I wanted, right? So x is one of those things that if you get two different options on it, that's not what you're looking for. So for when we're talking about these, what makes a relation a function is there's no repeated x values. You do one thing, you should expect the same thing back every time. You push the Coke button, you should get a Coke, right? You hit the Snickers button, you should get a Snickers button. If you never know, if it's a guessing game, that's not really a good thing that you want. Okay, so very first thing we're going to do with this one is that if we're talking about finding inverses, is you may get a list of numbers. And it may ask you just to find the inverse. Okay, so it may be a list of ordered pairs. It might be dots on a graph. That's a -7, yes. Oh, sorry, that's a 1. Yeah, 0, 1, 2, 3, -4, 5, and then 6, -7. Okay, it could be a list like this. It could be ordered pairs. It could be a mapping. I don't think they'd quite go mapping in this case, but usually it's going to be one of those two options. And they're going to ask you, okay, here's this function that we have, or this relation. They're going to ask you to find the inverse of it. And the inverse is just really pretty easy. Again, you just switch the two numbers. So make it 1, 0, 3, 2, 5, -4, and then -7, 6. Okay, so inverse is, again, you're just switching the x and values. Okay, and then usually after this one, what they'll ask you to do is they'll ask you, is the inverse a function? Again, from that point of it, you're looking at just the x values. None of them repeat, so it's good to go. They might ask you to do the same thing on the original part you got here. Yeah, so they may ask you, is this a function or not? So if they do that one, again, you're just looking at these x values. So that one, still yes for that part. Okay, so they give you the ordered pairs. It's easy enough. Now, here's where they're going to give you one, and this is really kind of where we're going to, because this is where we get this, and then we'll kind of tie the first thing and this together to get the last thing we're looking for. Is when they talk about, besides just giving a list of ordered pairs, if they give you a function, they're going to talk about inverse notation. And inverse notation is, instead of just being f of x, it's f negative 1 of x. Kind of when we had it, it's not really an exponent. It's just, it looks like an exponent, but it's really just the notation of it. And just like when we had, negative exponent, how we would say it was in the wrong spot, we had to move it from numerator to denominator. This one's kind of the same thing, that if they give you the f negative 1, they're letting you know, okay, we're going to do the inverse. We're kind of going backwards on this one. So to actually find the inverse, you're going to do 4 things with an equation or a function that you have. Okay. And the very first thing is we're going to replace the f of x with y. So the first step's not even really any math. It's just more of kind of cleaning it up to make it look a little bit better. To make it less of a function, more like an equation. And then we're going to do like we did up here. Now we're going to switch the x and y. And then once we switch the x's and the y values, we're going to solve for y. Okay. And usually that's where we kind of stop, but there's always that one extra step that we've got to do, because now we got to solve for y. The last thing is we're going to go back and put in that we're going to replace the y with f negative 1. Okay, so really it's 3 steps. The last step, step 4, is more of just getting the notation so that you know it's different. It's not f of x, it's the inverse. It's the f negative 1 of x. All right, so let's find the inverse of 2x minus 3. Okay, now one little thing that we'll go back and talk about what we were talking about yesterday a little bit. If we're talking about the domain on this one, if it's a function, the domain should be negative infinity to infinity. Okay, for the range, any fractions?
No.
Nope. Any square roots?
No.
Nope. So same thing, right? It's infinity to infinity. It's all real numbers. So you need to put negative infinity to infinity. If we're just talking about it, that's the double-legged R like we were doing yesterday. Okay, so we've got this function. Domain is, and again, if it's a function to start with, the domain is always negative infinity to infinity, because that's what makes a function. A function is you can plug in any number you want to, and you will always get one answer for one number. You'll never get 2 answers for one number. Okay, so to find the inverse, first thing is we're going to take out the f of x and make it y equals. And then after we take the f of x out and replace it with the y that's here, then we're going to switch the x and the y. So make the x go here and the y go there. So x is going to equal 2y minus 3. And then now you're going to solve this equation for y. And don't worry about that's just because some people some of y'all get a little freaked out because there's an x over here. Just forget about this one. If it's 2y minus 3, and let's just pretend that was a 4 here or something. If it's 2y minus 3, first step is you're going to add 3 to both sides, right? So that means that's going to be x plus 3 equals 2y. And then to get y by itself, we're just going to divide it by 2. So then we've got y would equal x plus 3 over 2. So again, instead of y equals, just do f negative 1 of x. And that's x plus 3 over 2. Okay, now, and the big thing is with inverse, is that everything should be the reverse operation of what you had in the original. Notice in the original, it was x minus 3. This one's x plus 3. It was 2 times x. Now it's x divided by 2. So anytime you're doing inverses, it's always going to be the opposite of what you think. Because again, inverse, everything is swapped. So everything that was addition becomes subtraction. Everything that was multiplication becomes division. Square roots become second powers, all that kind of thing. So,
Can we use that as like a cheat method?
You can't now.
For this circle one?
You can. Now the only thing is sometimes the order and how you do it has to be specific. Like for this one, if you had x over 2 minus 3, that would be still the same thing, but that would actually be wrong. And it's almost one of those where this is it's just 2 times x, where it's just the x is multiplied by 2. So the opposite of just doing the x is now we're going to do the x and the 3. So it's, you kind of know it's going to be, everything's going to be the opposite inverse operation, but it's just a matter of getting it to match up and line up. So you kind of know what the answer is going to be. You just got to, make sure all the details are kind of there. All right. The good news is if the domain was negative infinity and the range was infinity to infinity, if you switch the x and y values, which is your domain and range, they're still going to be the same thing. Because if they're the same thing when you start and you swap them, they're still going to be the same thing when you finish. All right, let's give you one that's just a little bit tougher. And we're getting close to the end. So. All right, so let's say example 2, we're going f of x equals x squared minus 1. Okay, so for this one, your domain, again, is always all real numbers. If it's a function, it has to be that. Your range, though, if you do x squared minus 1, now here's where we're going to take it back a little bit. If you got to graph this one, ooh, this is a good review question. If we're graphing x squared minus 1, what is that graph going to look like?
Parabola.
Yeah, x squared is a parabola, all right? The minus 1 is, there is no parentheses, right? So it's not in the parentheses, it's outside the parentheses. Which way is that 1 going to make us go? Up, down, left, right. Everybody remember? Down 1, right? Yeah, so normally where x squared would be like this, we're going to move it down 1 space. So x squared minus 1 would be something kind of like that. So your range is this thing is going to be at a low point of -1 and it's going up to infinity. So this one would kind of be your range, would be -1 to infinity. That is a fantastic review question. Because we hadn't done the graphs in a while, so it was kind of good. Didn't even really mean for that to happen. It was like, oh, let's graph it. Let's see what happens there. Just a sketch, not super detailed, but just kind of thinking about it. Okay, so now let's go ahead and find the inverse of f of x equals x squared minus 1. Okay, and I always go ahead and like to do the first thing. Go ahead and take this f of x and just rewrite it as y equals x squared minus 1. So we can get that out of the way without having to rewrite it once again. Switch your x's and your y's. The squared, correct, the squared stays where it is. So you literally just take the x over here and the y goes over there. Everything else around it stays where it is. So now we're not just getting y by itself, it's the y squared that's getting by itself. So first thing is plus 1. So we've got it down to x plus 1 equals y squared. How are we going to knock it from y squared down to just y? What do we do there? Square root, right? There you go. So we're going to square root it. So when we got x plus 1 equals square root of y squared, that's going to cancel out and get us the y equals there. And that one, there's nothing you can really do to simplify that one. So that is the answer for the inverse there. So it's x plus 1. And instead of being y equals, we're going to put f negative 1 equals. Okay, now, and here's where, as long as they're assuming everything is positive, what they're doing for this one, sometimes they may make you go plus minus here. Because technically, if we started off with y squared, we need two answers, right? Or if we even go with x squared on this one, we're looking for two answers. So to get the two answers we're looking for, we do a plus or a minus there. Okay, now here's where you don't have to overthink the domain and range, because domain and range were these two numbers. Again, domain is your x values and range is your y values. So when they ask you to find the domain and range of the inverse, you just switch these two answers. Now, the negative 1 to infinity is the domain, and then the negative infinity to positive infinity is your range. So just switch them up. Okay, and then they may ask you then, all right, so now we know what the inverse is. Is it a function? Do we use every single x number in that case? We don't, right? Because we're cutting off. We're saying you cannot go below negative 1. So a function is you get to use every single number, and you can plug it in. Because we switched these two up now, the domain is at negative 1. Basically, all these other negatives down here from negative 2 down to negative infinity, those aren't even an option. Because if you do square root of a negative number, it's no solution, right? It's not a real number. So in this case, because we're leaving off this part of the domain over here, it actually would not be a function. Again, functions, the domain has to be from negative infinity to infinity.
So why does the domain range change again?
Oh, because technically for the inverse, you're switching the x's and the y's. And technically, domain is your x values and range is your y values. So if this is your x and y values, then when we go to the inverse, we just switch where they are. Because now this becomes your x and then this becomes your y. So you just take these two answers you've got and just flip-flop. Okay, one more finding inverse, and then show you one little thing, and then we'll wrap this thing up. Okay, so f of x is third root of x plus 7. I'm going to find the inverse. Okay, and again, instead of f of x, it's just y equals. Switch the x and the y, so the x goes here, the y goes there, and again, everything else around it stays exactly the same. So now it's the third root of y plus 7 instead of third root of x plus 7. Okay, same setup. You've got the y plus 7, so we're going to subtract 7 from both sides. But how do we get rid of the third root of y? Yep, just cube it, right? So whatever this index is, you just take that to the power. That way, those two things knock each other out. Now, and then you do not have to, here's the thing when you get to this one, you do not have to do the full method out on this part. If it's x minus 7 cubed, just leave it like that. So f negative 1 of x is x minus 7 cubed. Because again, the opposite of third root is x to the third. This plus 7 was on the outside. Now we've got a minus 7 that's on the inside. So everything is flip flop. What was outside is inside. What was plus is minus. What was up was down. What was roots becomes powers, and so everything just totally gets flip flopped there. If you had to, now, not, I don't know if we graph these a lot, but third root of x, that's basically like the square root, but it would come in and do something like that, like a sideways S. And then x to the third power, remember that was the one up, one down thing? Would have been something like that if we were graphing those. Okay, and then last thing. Oh, and if this was your graph here, domain and range in this both cases would be negative infinity to infinity. Because no matter what you do, if you can cube root a negative number and get an answer, that's okay. So cube roots, again, you don't leave any numbers out. So for this part, this one would also be the same thing. Domain and range would still be negative infinity to infinity for both of those. Okay, and then the last thing. And after this, I'll show you a little video. Okay, so the last thing they're going to do is they'll give you two functions, then they'll ask you, okay, don't find the inverse of it. Here's two functions. They're going to ask you, are these two function inverses? Now you could, take one and find the inverse of it and go that route with it. But in this case, basically, here's what you can do. You either find f of g of x or g of f of x. Which one you find, it doesn't matter. If you find g of f of x or f of g of x, if the answer equals x, the functions are inverses. If you get anything else other than x, if you get x plus 1, if you get 3x, if you get x minus 7, if you get anything other than just a plain old x, it's not. Negative x is not inverse. It has to be just an x by itself. So if there's anything else with x, if it's negative x, if it's x squared, if it's square root of x, if it's x plus 2, if it's x minus 1, anything other than just a plain old x is not an inverse. Okay. So R, f of x equals x over 4 plus 7, and g of x, which is 4x minus 7. Are those two function inverses? Okay. Again, it doesn't matter whether you do f of g of x or g of f of x. You just take one function, plug it in the other function, and see what you get. The order doesn't matter because if they're inverses, either way you go, you should get an x for that part of it. So for this one, I'm just going to take the first one and plug it into the second one. So it's going to be 4 times x over 4 plus 7 minus 7. Because again, if you look at them just on paper, they look good. This one's 4 times x. This one's x divided by 4. This is x minus 7. That's x plus 7. So if you look at just the operations, the inverses are all there. It's just, is the order correct? Did they do it the right way that it should have been done? So if you do 4 times this and 4 times that, those 4s will cancel and get you just x. But 4 times 7 is 28. And if you do 28 minus 7, that is 21. So if we do f of g of x in this case, then we get x plus 21. So are they inverses? No, it's got to be just an x. Okay, now here's one that kind of make your head hurt a little bit. Just real quick. So f of x is 1 over x, g of x is 1 over x. Are they inverses of each other? Well, you're like, it's the same thing, right? Yeah. So if we take the same thing and plug it into itself in this case, we get 1 over x. And then if we keep it, change it, and flip it, we get 1 times x over 1, which is just a whole lot of 1s and an x. So yes, 1 over x is the inverse of itself, which seems a little odd. Because sometimes you do stuff and it just doesn't make sense, but that's just, when you check it, that's just what it is.